So this is lesson 6.1, B as in boy, in trig, and we're continuing on with our inverse sine function. This is top of page 239, and a couple things that I just wanted you to look at is this right here. This is our inverse sine function, so we're taking our sine function that looks like that, flipping it, and it makes it look like that. And what we're looking at is a couple things here. Our domain is -1, 1. So that's all. If your x values are bigger or smaller than 1 and -1, it doesn't exist, just like the last example we did. And our range, which means our x and y value, are no bigger than -pi/2 and +pi/2. It won't go any further. So it's all within this square. Any numbers down here, up here, over here, or over here do not make this a true statement. You will get an error on your calculator. So something to remember there as far as sine. And cosine and trig will have the same idea. It will give you a domain and range, so you kind of know within what boundaries you're looking at. Talks about the inverse sine function is increasing and continuous, which means when you start here, it gets higher and higher and higher. Your range gets higher. And it's continuous. There isn't a break. It's just a nice smooth curve. Nothing weird happens. If it wasn't continuous, it may go up here and then stop, and there would be something broken here. So that's what it means by continuous. And let's see. Gives us the x-intercept is 0, y-intercept is 0, which means it crosses there, and it's symmetric and it's an odd function, which we won't go into the odd function part of it right now. But anyway, that's what it looks like. Sine -1 of x, arcsine of x. Alright, so let's look at cosine, or inverse cosine of function. And I'll just put a picture on there real quick. So notice the inverse trig function, or cosine function here. It's going to be written the same way, only we're just replacing cosine instead of sine like we did on the other one. We had sine, so we're using cosine, but everything is the same. And we're taking this curve right here, and notice the difference, because remember the sine wave started here and went up like that. And so flipping it across this line looked different. Alright, so if you look at the one we have here on the right, that's the inverse. See, notice it gives us the inverse right there. And my domain, the furthest to the left I get is -1. The furthest to the right I get is 1, which is just like my sine wave. And the highest up it goes is pi. And notice it does not go below this line here. Okay? Whereas the sine wave went below the y-axis, the cosine wave does not go below the y-axis, so that's why the interval is just 0 to pi. Because, see, notice, if I went further this way, then I would cross 2 points here with my horizontal line. So I had to start at 0, and I go to pi, which means in the domain, or the cosine wave, 0 to pi, here I'm at -1 to 1. Okay, and my pi is here and my 0 is here. So remember, kind of everything flips, so that my domain here from 0 to pi becomes my range here, my y, 0 to pi. So it doesn't cross the 0 axis in the y area there. So let's look at example 2. Find y. It gives us y equals the arc cosine of 1. So again, you're putting 1 in your calculator and you're hitting that arc cosine button. And when you do, you get y equals 0. So that means that when you have this here and you are in the first quadrant, you have a 0-degree angle basically, so it's this line right there. And just to remind you, cosine is adjacent over hypotenuse, so that's saying that the adjacent is a number and the hypotenuse is a number, and they're the same. Because your arc cosine is 1, which means your ratio is 1. So what angle has a ratio of 1? Well, the angle that has a ratio of 1 is one that has the adjacent and the hypotenuse as the same. So if I had an angle that looked like that, and it's getting smaller, so let's say it's moving this way and getting closer to 0, what happens to the hypotenuse and the adjacent? Well, once this becomes 0, then my hypotenuse and adjacent are on top of each other, which means they're the same number. So it doesn't matter what number you put here. You could have, 4 over 4, doesn't matter. When they become the same, that means they're on top of each other, which means there is no angle there. Okay, so that's where they got that as far as 0 is concerned. Now, if we look at the next example, if I can get rid of this, we've got y equals arc cosine or cosine of negative 1, negative square root of 2 over 2. All right, we're dealing with cosine, and we can draw the figure if we want, and we know that cosine is adjacent over hypotenuse, and we know that the cosine is positive there and positive there, so we know it's got to be over here in quadrants 2 and 3. So if adjacent is, or cosine is adjacent over hypotenuse, it's going to have to be over here. So that gives us negative square root of 2 for my adjacent and my hypotenuse right there. So it could be down here as well. It would give you the same ones there, but you do remember from our drawing that it can't be below the y-axis. So it's got to be in this quadrant. So I know that in order for this to take place, I can find this angle right there using Pythagorean if I have any interest, which I really don't. But it's that angle, so I'm going to take the square root of 2 over 2 and then take the arc cosine of that, and actually I can look at this and know that this and this are going to be the same, because if I take the square root of 2 plus the square root of 2, is that going to give me 2? Well, this is going to give me 2 plus 2 squared equals 4. Yes, that works. So these are the same, which means that this angle here has to be a 45-degree angle. And I know that a 45-degree angle in that second quadrant is, well, a 45-degree angle is pi over 4 plus pi over 4 plus pi over 4 is going to be 3 pi over 4. Okay, so I know that what I'm looking for is 3 pi over 4, and that ends up being my y value. That's my angle, 3 pi over 4, or a 45, 45, 90, 135 degree angle, 345s. So anyway, hopefully you're kind of following what I'm doing there, because sometimes I get carried away and I start thinking in my head instead of explaining everything that I'm doing. Or we can take the square root of 2 divided by 2, and then take the arc cosine of that, and you will get, promise, I just did it, you will get a 45-degree angle, which is this one right here. So you will get a 45-degree angle there, but you have to realize you're in this quadrant, which means the angle is going to be this angle right there, which is going to be 3 pi over 4. So you're going to have to take your pi minus your 45-degree angle, which is pi over 4, and that's where you get your 3 pi over 4, which is this angle right here. So that's why I like to do these handy-dandy little drawings. It helps me to know which interval I'm in, or which quadrant I'm in, and it helps me to realize where I'm at. So anyway, we get 3 pi over 4 for that. And if you look down at the bottom of page 240, it gives you the inverse cosine function. It tells you the domain, tells you the y-intercept, and all of that. All right, so continuing on with the tangent. Tangent is the exact same. The only difference with 241 is that our inverse, we have a domain of infinity. It goes to the left and right into infinity if you look at the picture there. So notice, my x, it goes into infinity that way, it goes into infinity that way. My range, my y value, the lowest it can go is pi over 2, highest it can go is pi over 2. So if you look at the top of page 242, not going to really use those, but it gives you the domain and the intervals and the quadrants on the unit circle that those are going to appear in. So let's jump to example number 3 in this next video and continue on. Broken there.